Page 96. So this is our Haworth projection worksheet here. Now, sometimes when we have a ring, we get a hexagon here. When we have a hexagon, the oxygen is usually up in the upper right-hand corner, and this is what we call a Pyranos ring. Sometimes, however, as with ribose in ribonucleic acid, we might see something that looks like a pentagon. Now, this can be it can be a 5-carbon sugar, it can be a 6-carbon sugar, it could be even a 7-carbon sugar. This could be a 5-carbon, 6-carbon, 7-carbon sugar or something crazy like that. But typically, this is how you see ribose when you see DNA or that ribonucleic acid. So here's the thing. The first thing that you want to do is you want to figure out if you're going to be drawing a Pyranos ring or the Pyranos ring. F5, that's how you remember it. Okay, P doesn't stand for anything, so it's F5, so Pyranos is going to be 6. So I'm going to model how you're going to do this. So it'd be good if you just watched and then maybe if you want to replay it. So the first thing you have to look at is what I want you to do. And so you're looking at the molecule. You can go ahead and number it if you want to. Always number. Even when you get good at this, it's such a good idea to number because those people who don't number tend to screw up more often. So we have 6-carbon sugar. We're going to draw the alpha form. So if you think of this, alpha is a little fish. So that means my hydroxy, my new hydroxy, is going to be drawn downward. And it's a Pyranos ring, so that's going to be a hexagon. The Pyranos ring is going to be a hexagon. So before you do anything else with this, it's a really good idea to kind of practice drawing these. So when you draw your Pyranos ring, you immediately know that you're going to have to, oops, I shouldn't have done that. You have to have an oxygen up here. So ideally you don't draw through it like I just did there. So go ahead and you draw that hexagon. Keep your oxygen up here. Don't be fancy and give me a mirror image or anything. The Pyranos ring is actually a little bit easier to draw. So if you have a 5, it's like this. Please do not draw me a house. Alrighty. Remember, the house has walls that are sideways on the bottom coming inward. So this is going to be Pyranos. That's going to be a Pyranos. So this is really how I should have done this. That's a 6-sided sugar. You don't really have to worry about these connecting because you're going to be drawing a line through them eventually. So I look at this sugar and I say, okay, self, what do I have to do here? I've got to make a Pyranos ring. So if you're smart, you're going to do this so that your Pyranos ring is actually fairly big because you got a lot of stuff to put in there and it's a lot less confusing if you draw big. So draw pretty big here. So I have an aldose up here. So this is where my reaction is going to take place. Over here, I've got a ketose. This is where my reaction takes place. It's always at the aldose or the ketose. So when I look at this, I know that my new hydroxy is going to be down. So the first thing I'm going to do is I'm going to put these little lines in. 1, 2, 3, 4, 5. That's all we need. And since I have an alpha form, I can immediately look at this and I can say, okay, this is going to be where my carbon 1 is. This is where my 2 is going to be, my 3, my 4, my 5, and my 6 is going to be up here. Sometimes you can just go ahead and just draw that CH2OH in there, all right? Now, at that point, you're pretty much done. But let me tell you what's going on here. If I have a Pyranos ring with a 6-carbon sugar, that is going to be exactly what we just saw on the previous page. We have a 6-carbon aldose, and we're drawing a Pyranos ring, except we're drawing the alpha hydroxy group down. So what I looked at here is I say, okay, my first carbon here is going to be where the reaction takes place. So this is carbon 1, and we don't have to draw that C in there. This O here is part of the new OH. So I'm just going to take this and I'm just going to go whoop. That is part of your new hydroxy group. This is a new hydroxy group, brand new. So if this 5th carbon, see where I have the 5 connecting to the new oxygen. So if this hydroxy on the 5th carbon reacts, this is where this oxygen here is where my O goes. Okay, this is where my reaction takes place, the hydroxy on here, and this is where my oxygen goes. It would be a good idea to go back to the chapter where we had the aldehyde and ketone reactions, and kind of look at a hemiketal and a hemiacetal and see how when you draw these, or open chain or closed chain, especially the closed, what's going to happen when you have that reaction. So all you got to do now is this. I look at carbon 2. I go, okay, if this is 1, this is 2. We always number clockwise. That means that my hydroxy is to the right. Then I draw it down. Now, because it gets really, really ugly, only draw the hydroxys. You know that there's going to be a hydrogen there, but it gets really kind of crowded when you start drawing all that in. You go to carbon 3 and you say, oh, look, the hydroxy is to the left. And so it's HO here, so I'm just going to put a HO here. Okay, to the left, up, to the right, down. 4, again, the hydroxy is to the left, so it's going to be up. Now, this is where everybody gets screwed up. So this carbon here, carbon 5 is this carbon. There's a hydrogen here, we're not seeing it. And then we have a CH2OH, and that's up here. It doesn't react. Now, this oxygen belongs to this carbon right here. So where do I put this hydroxy? I don't put it anywhere. This reacted, and as a result, this oxygen is left over. So we do not put a hydroxy anywhere where that carbon that is going to react with that aldehyde functional group. Okay, so let's just practice. If we have 6 carbons, that's going to be a hexose, and so this is going to be an aldohexose, and you have to be able to categorize those. Aldohexose. All righty. So I'm going to go down to C before I go up to B. So if you look at this, you go ahead and number 1, 2, 3, 4, 5, and 6. You have an aldehyde. And then you have a pyranose ring again, and you have a beta form in this case. So if it's a pyramose form, that means you have 6 sides. So zoop. You guys are going to be really good at drawing hexagons by the end of the semester. So in this case here, this is going to be, the aldose is where the reaction starts. Sometimes kids have trouble with this. If this is where the reaction is, then this is my first carbon right here. So this is 1, 2, 3, 4, and 5, and my 6 is going to be up here. You don't really have to number these. As long as you can keep it straight, you're good to go. But you have to remember, your reaction is at the end of this chain. There's not going to be anything left over here. You're starting with this aldose at the top, 1. Alrighty. So it says I have a beta form. Birds fly in the sky. So my new hydroxy group that forms as a result of the reaction between the 5th carbon and this aldose group can be right there. So number 2, it's left. Left is up. So 1, 2. We don't need to put that hydrogen there. If it makes you feel better, go ahead, but you better have a big hexagon. 3, hydroxy's on the left, so we go up. 4, ding, ding. Hydroxy's on the right, so we draw that one down, or ho. Now, stop, think, and listen. You've got your 5th carbon here. That's where the reaction took place. You now, when this reacts, you're going to have a hemiacetal. I know it's kind of hard when you're looking at it this way. I'd encourage you to draw it out and try to figure out why we're calling it that. Okay, so here's your hydroxy that is going to be reacting. So I do not draw a hydroxy up or down here because this buddy has reacted and it's gone. It has left its carbon behind. This is from carbon 5 reaction. Okay, that's a C5. So what do I do here? Nothing. I move on. My 6th carbon is going to be up here, and that's where I have to draw my CH2OH. And there we are. I think it's actually kind of harder to take these apart than it is to draw them out, but that's just me. Okay, so these are both what we call pyranose rings. They're both 6 carbon sugars. This is an alpha form here, and this is the beta form where you have your hydroxy up. Birds up. Okay. Now, you're going to see two ketoses here. So we have a 1, 2, 3, 4, 5, 6. We again have a 6 carbon sugar. But in this case, we're going to draw a furanose ring. So your O goes at the top. Make your ring nice and big so you have plenty of space. Now, your reaction point, folks, is right here. Now, sometimes you don't know actually where your reaction takes place. This hydroxy could react, but this hydroxy could also react. It would be rare for this one to react because it's too tight, okay? So you have to kind of think this through, and you just have to see how it plays out, but you have to be very careful. If your reaction point is on carbon 2 and the carbon 1 remains unreacted, what that means is that this right here has to be drawn as unreacted, and it's going to be either drawn up here, CH2OH, or it's going to be drawn here, CH2OH. How do we figure out where it's drawn? If we have an alpha form, that means your new hydroxy is going to be down, and so therefore this unreacted CH2OH section of the molecule is going to have to go up. The only way you know it's up is by looking to see what form you have. So this second carbon is where the reaction takes place. So this is 1. This is actually 2 now, 3, 4, 5. And just like before, you know, you're kind of done here. So your 6th carbon is going to be drawn up here. And it's going to stay, this part is going to stay reacted. So we go ahead and we say, okay, what happened here? Well, we don't care what happened here because this is where the reaction took place, and that's my new hydroxy. So this is carbon 2, carbon 3 left is up. 4th carbon, hydroxy is to the right. So we're going to draw it down. 5th carbon. Now you have to stop and think about this. Look here. The 5th carbon's hydroxy group reacted. Okay, this is part of carbon 5 hydroxy group. Okay, so when we draw 5 here, we're really essentially, that's all we have to do is we already put that oxygen in there, so we don't worry about drawing that. But I do go up here to carbon 6, and I have to make sure I tell everybody that that 6 is up here and it's unreacted. So your reaction took place, bam. Okay, so this is an alpha form, your hydroxy was down. So typically, not always, and you're going to find that out, but typically when you see an aldose and it reacts to form the ring, most of the time that aldohexose is going to give you a pyranose ring. Okay. If, however, you have a ketose, and in this case here, we have a ketohexose again, a little bit of practice. If the typical reaction takes place where you have your carbon 5 hydroxy reacting to this carbonyl carbon's oxygen, then you are going to have a furanose ring. Okay, so your ketoses 5 and your aldoses 6, hexagon versus pentagon. Now, this is not always true. Sorry about that, off the screen. This is not always true, so you're going to have to keep your eyes open. Okay, stop if you need to see this. Sorry, I was off the screen. I'm trying to keep it on with my paper that's taped down, but I'm not succeeding very well. Okay, so we have one more ketose here, and in this case, we're going to have a beta form, and we're going to have a pyranose ring. Now, I just got done telling you up here that typically, if you have a ketose, you're going to get a furanose ring. But then I cautioned you and I said, but that's not always true. This happens most of the time up here, but you're also going to get this happening too. So if you have a pyranose ring, go ahead and draw that in. So if you have a pyranose ring there, that would mean you have one more side. So instead of the 5th carbon being bonded to that oxygen, now what's got to happen is, because you have one more side, it's actually the 6 carbon's hydroxy that reacts here, and you're going to see that very shortly. Number them up: 1, 2, 3, 4, 5, and 6. Okay, and then over here we're going to have to wait to number, And why are we waiting? Well, because we have to see what happened to the first carbon. If the first carbon remains unreacted, boom, it's going to either be up or down. How do we tell? Well, if I have a beta form, the new hydroxy, like a bird, has to be up here. So that would mean your unreacted CH2OH is going to be down in this case, okay? So this is unreacted, nothing happened to it, so it's got to be down here. So what does that mean? That means that this is 1. Okay, so my second carbon is here. This is my third, my fourth, my fifth, and check it out. You know already that this is your 6th carbon, because if you number, you're like, oh yeah, okay, that reaction took place right here. There's nothing that you have to draw up or down because this is your final carbon, all right? So this does happen. It doesn't happen as much as this happens, but let's just go ahead and finish drawing it now, okay? So if I look at my first carbon's down here, second carbon is right here. It's bonded to the new hydroxy. I always tell people, no, don't forget it. Okay, third carbon, hydroxy to the right, that's down. Fourth carbon, right, down. Fifth carbon, right. And we can draw this down. Whoops. Yes, down. And look, the 6th carbon is where the reaction took place. It's right here, and it's bonded to this oxygen. This oxygen was this oxygen. This oxygen right here is this oxygen right here. That's where your reaction took place. 6th carbon, new oxygen. So if you look at this then, if it's your 6 carbons hydroxy that came off, okay, then what do you have left? Here's the oxygen to the hydroxy. Your hydrogen goes with this guy right here. So really the only thing you have left is CH2. This is gone. So here's your C, here's your H, and here's your H. You don't draw hydroxy because it is gone. Bye-bye. Okay, so that tells you how to get from the Fisher to the Haworth. Keep in mind in solution, they're constantly going back and forth. They open, they close, they open, they close. The open is going to be less frequent than the closed, okay, but when these guys are dry, they're pretty much going to be in straight chains, okay? So I'm going to go on to page 96 right now. By the way, if somebody could take a quick picture of, let's see, 97.5C and 97.5D, I would like to use that. I do have one copy, but I want to try to keep it so that it is not written on. I want to try to make a copy. Thanks, and I don't have those with me. That's 96.